Hello everyone. So in this current lecture that we'll be having, in this we'll be discussing about a topic called sets. So this is the second segment if we talk about this whole bigger topic that's called numbers. So in that sets is a particular segment. Okay, so I'm telling you, as I told in my previous videos also, there are 18 segments that we need to discuss in numbers, and out of that set is basically our set is basically our second segment. Okay, so we are going step by step, so don't worry. Okay, so this is the syllabus that we need to cover when we talk about sets, and it's very easy. Okay, so what we need to cover in sets, so we need to understand and use set language. We need to understand how to write the notations, Venn diagrams, and how it can be used to describe sets and represent relationship between sets. So that's the thing that we need to understand with time. Okay, then, so they have given you the example also that when diagrams are limited to 2 or 3 sets, the following set notation will be used. Just like this, these are the symbols that will be used frequently, and then I will be explaining it to you. Don't worry about it. And these are like the definition of sets, about which I will also be discussing. So don't worry about it. Okay. And after that, we'll be doing a lot of questions. So a lot of coverage will be done at the end of this particular topic. So don't worry about it. Okay, let's understand the symbols first. Okay, the first symbol about which we need to talk, it's called intersection. Okay, now what does it mean by intersection? So intersection means that how many common elements are there, that is marked under the criteria of intersection. For example, first let's understand the sets only. Okay, sets, I think that you must be knowing, but I'm revising the things up. That sets is basically a collection of well defined objects. Okay, so that's known as the sets. Okay, you must have studied in the previous classes also. Okay, and then the point is that if we talk about sets, what does it mean by well defined objects? So yeah, we can't just keep like it like that, the weathers of India. Okay, not like that. Okay, not where something probability is there. Okay, some probable statements are there. No, not like that. Very well defined. Just like if I talk about that, how many states are there in India? So we can write those 28 states over here in the sets. And if we are writing it down, we just write it in this parenthesis every time. Okay. And we can start from Delhi, not Delhi actually, Delhi is an union territory. Okay. We can start with Maharashtra. Okay. Then we can move to Uttar Pradesh, Karnataka. Okay. Karnataka, West Bengal, etc. Okay, no, you should not write etc. But yeah, I'm telling you that where there are many states, so you can mention all of them over there. Okay, so that's how we just define the states of okay of India in the form of a sets. Okay, so sets are nothing but it is the collection of well-defined objects. That's it. You need to understand. Now, if I move on further, okay. So what does it mean by intersection of sets? So it's also very easy to understand, okay, that it is always about the commonalities that or the common elements between two or more sets, that we take it an intersection. Okay. So as I told you, sets is a collection of well-defined objects. Yes, one more thing. In a set, we can't have duplicate elements. Okay, we can't have that. What does it mean? That let's say if somebody asks you to write the numbers, okay, they have given you this set, that there's a set A which is given by 1 2 3 4 4 5. So this kind of set does not exist. Okay, instead of that we can write it as 1 2 3 4 5. Okay, so this is correct, because in a set we can't have duplicate elements. That's the first and foremost thing you need to understand. Okay, I hope you must have got it. Okay, so if I talk about intersection again, let's go back to the topic. Let's say if I'm having two sets, the first set is having the elements as 1 comma 2 comma 3 comma 4. And let's say if our second set is having elements like 3, 4 and 5. Okay. And if somebody asks you what is A intersection B, so that means they are asking you to find out the common elements between this set A and set B. And if you can just see 1 and 2, if you just see, these are not common, but 3 is common in both of them, 4 is common in both of them, 5 is not common, it only lies in set B, so we won't be taking that. So A intersection B will be actually 3 comma 4. Okay, that's how the basic starts. Hope you must be getting it right now. Okay, now if I move on further, and the next thing is actually known as union, union of sets. Now what does it mean by union of sets? So we just keep what all the elements present in both the sets in this final set. For example, if we are having A and B, so in A we are having 1, 2, 3, 4. Again, let's go with that. And in B, we are having 3, 4, 5. So in A union B, we'll be writing all those elements present in both A and B. So just like 1, 2, 3, 4, 3, 4, 5. But as you know, we can't have duplication in sets, so we'll be writing the simple ones only. So 1, 2, 3, 4, 5. We will be writing the common elements only once, not twice. And that's how we write down the sets. Okay, the union of the sets. Okay, so you may have observed one thing over here, that while adding the things up, okay, from the two sets that we are having, what we did, we just had the elements from set A, then we added the elements from set B, and then we subtracted the common elements present in both for one time. Okay, so we just subtracted A intercept B. So this is a very important concept that we need to discuss further when we'll be talking about two or more sets. Okay, so please keep this thing in your mind. Okay, so I hope that there won't be any kinds of doubts after this. So intersection is like we are trying to take out the common elements between the two sets, and union is like then when we are trying to find out the all the elements present in both the sets, or even though three sets. I'm telling you for your exams, as it has been specifically being mentioned in the syllabus also, that it will be mostly about two or three sets. Particularly about two sets, majority of the question comes. Okay, but questions can come from three sets also. So we will be practicing the things up. So don't worry about it. Okay, and it will be very easy for you. Okay. Now let's talk about this. Okay. Yeah. Okay, so let's discuss the things further on. Okay, so the next thing that about which we need to talk about is called the subset. But before that, okay, I may have forgot you to tell this thing to you, that if we talk about two sets, okay, and as I told you that intersection means the common elements between the two sets. Okay, so it will be represented by the part which is common while we are making the Venn diagram of both. Okay, so you can see that in this case this will be our answer for A intersection B. But if we talk about A and B, it includes all the elements present in both A and B. So in that case, it will be the whole shaded region like this, whole part. It will be coming over there in that particular region. Fine. The next thing actually about which we need to discuss is called subset. The subset is very, very easy to understand. Very easy. Okay. What you need to understand, that subset actually means part of a set. For example, if I'm having a set 1, 2, 3 and another bigger set B 1, 2, 3, 4, 5. So in this case you can see that whatever elements are there in A is lying in set B also. So what we can understand from here, that A is the part of B. Okay, so in this case we can say that A is a subset of B. And what we can just imply from this, okay, this implies that A can be written as A is a subset of B, like in this notation. So this symbol means subset. Okay, understood? That's how the thing goes on. And the other thing is actually, let's say if I'm having another set, A as 1, 2, 3, 4, and B as 1, 2, 3, 4. So in this case, you can say that A is a subset of B. But wait a minute, we can see some difference over here for sure between this and this. Here, this symbol is used, and here this symbol is used. Okay, so what's the difference? You can see from here. This symbol means that A lies inside B but cannot be equal to B. So that means that all the elements in A will always be lesser than whatever elements are lying in B, for sure. But when we are using this symbol up, it would mean that that this elements in A, the elements lying in this set A can be exactly what is lying in set B. It's like that. Okay, so hope you must have understood. So this is the symbol for is the subset of, and A can be equal to B. For that we use this particular symbol given below. Okay, but there's one more symbol. Okay, because if you just see over here, A is definitely a subset of B, but we can't write like this. Is B a subset of A? No, because all the elements of B does not lie in A. Okay, in A we don't have 4 or 5. Okay, so in that case this is not possible. B is not a subset of A. But instead of writing this like this, crossing the things up, we write like this in a very proper notation. B is not a subset of A, like this. Okay, yeah. Now the next symbol that you need to understand is basically this symbol, which looks like a E, embedded E. Okay, and that is actually for belongs to. Now what does this mean? It's actually very, very simple to understand. Belongs to mean that it is actually describing a relationship between an element and a set. Okay, so here let's say in this case, if you just see A is having elements as 1, 2, 3. So we can say one thing from here, that 2 actually belongs to A. Okay, what does it mean? That 2 is actually a part of A. So we can write this symbol over here, belongs to. But let me ask you one more thing. Is 5 belongs to A? Does 5 belongs to A? No, it does not belongs to A. So for this, what symbol we use? We use a symbol like this. We make a E like thing, and then we just cross the things up and we make it. As simple as that. Okay? Hope you must have understood. Now the next thing is actually known as the universal set. Now what does the universal set mean? It means that it is the collection, it is the set of all the things that you are considering at a particular time. Okay, for example, if you are considering apple, banana, papaya, and so on. So in this case, universal set will be fruits, because the category that you are looking for is fruits. Okay, so that's how the thing goes on. Okay, so universal set consists of everything which is present over there, and it is represented like this. Okay, so there's a difference between the two symbols. Belongs to looks like this, where it looks like a C actually, in which we just make a line like this, and this universal set looks like this. Okay, so this is the difference. Universal set consists of all the elements. Okay, so I think you must have understood till right now. Fine. The next thing is actually called as, okay, yeah, the next thing is actually known as a complement. Now what does this complement mean? Okay, it is very simple to understand again. So complement of any set mean that we won't be taking, while we are writing the final answer, we won't be taking any element which is lying in that particular set, but I will be taking every element leaving that particular set and lying in the universal set. Okay, for example, our universal set is 1, 2, 3, 4, 5, and the set A is looking like this, 1, 2, 3. So A complement will be all the elements which are lying, which are not lying in set A but lying in a universal set. Okay, so in that case it will be 4 comma 5. It's as simple as that. Okay, so here you can also see how they have just made the Venn diagram over here. Okay, that here is our set A and here is our universal set which is consisting this set A. Okay, so we'll be shading all the region leaving this set A. Okay, so that's how we write complement of a set. Okay, so this is the region for complement of set A. Okay, and if we talk of, if we talk about this particular statement given over here, which says that A, that means the number of the elements lying in A, if we take the union with A complement, that means the red region, that will give us the universal set. That's for sure, because this blue region if we just shade and this red region which we already shaded up, if we just combine the things up, we'll be getting the universal set. So that's the correct statement. Okay, hope you must have got it, and we'll be moving on with the next part. So the hard part we are already done with. Now comes the very easy part. Okay, so the next part is basically about this particular symbol. Okay, n, and then in bracket we write the set name. Okay, now what does this symbol mean? It actually means, it actually helps us to count down the number of elements present in a particular set. Okay, just like you can see in this case, the number of elements present in this set A is x, y and z. Yes or no? Okay, so the number of elements over here will be how much? It will be 3. Okay, so that's why we wrote this thing up. So it's very easy to understand. The next kind of symbol is like this scientific, this word line notation that has been discussed over here. Okay, definition by sets. Okay, so either we can just write the elements directly in parentheses, or we can mention it up in the form of the statements. Okay, now let's just try to read it. So here there's a set A which, in which we are considering that x is the variable. Okay, x is the variable, and this colon is actually meaning such that. This colon means such that. So how we can read this thing up? X is an element or a variable such that x is an integer. So it tells us that x is an integer and x is greater than equal to 2 and lesser than equal to 9. Okay, so it includes 2 and 9 also. Okay, and we'll be talking more about this in inequality, so don't worry about it. So that means if we try to write in the parenthesis form, okay, so we'll be writing all the elements including 2 and 9, which should be an integer between 2 and 9. Okay, 2, 3, 4, 5, 6, 7, 8, 9, all will be there. And that's how we can write the answer for the set A. Hope you must have understood. Now the last thing that you need to think about is basically this empty set. Now what did it mean by empty set? So it means that no element is lying inside that particular set. For example, if something is written like this, A 1 comma, sorry, not 1 comma, wait, there's a mistake. Okay, just the set is written like this. Okay, so it means that it is an empty set. And if somebody asks you what is NA, okay, number of elements in set A, so you will answer it as 0. Okay, also this A can be mentioned as phi. This symbol is pronounced as phi. Okay, so these are the things that you need to understand. Okay, now remember, many people actually get confused with regards to this. Let's say inside this set, if I write 0, so does it mean that it is an empty set? No. If you need to understand the basic statement when we started the sets, that set is a well-defined collection of objects. Okay, so it's collection of objects or elements. Okay, so this will be considered as an element. The 0 will be considered as an element, not as a number. Okay, so in this case, the number of elements in A will be counted as 1, not 0. So you need to keep this concept clear inside your mind. Hope you must have understood. Fine. So these are the 9 symbols that you need to understand, and if you understand this thing up, sets is very easy. Okay, it can be completed in 1.5 hours. That's it. Okay, and it will be very super duper important when you will be going into your A levels or your DP studies, whatever you prefer in your future grades. Okay. Now, if we talk about, let's do the one question. So here it says that in the Venn diagram, the universal set is like people in a hotel. So that's our universal set. And T is like people who like a toast. So this cross actually represents the people who like the toast inside this set. Okay. Okay. Cross actually represents all the people. Okay. All the persons lying in that particular hotel. Okay. And whatever is lying inside T is basically reminding us that people who like toast. Okay. So basically this whole shaded region. Okay. This will be basically about the people who like tea, who like toast. Okay. And then E is there, that means people who like X. So this region. So you can see that leaving this E and T, there are many people who don't like E and who don't like either T nor or toast or X. Understood? They don't like toast or X, both of them. Okay, so you need to understand this thing up. Okay. So the question is, the first question they're asking, okay, that how many people like toast? That's the first question. So we can count the things up very easily. Okay, in the commoner part, we are having 1, 2, 3, 4. So 4. And here we are having 1, 2, 3, 4. So 4. So in total, it is the answer. Okay. Next one. How many people like egg but not toast? Let me just go with the red pen. Egg but not toast. So they like egg but not toast. Now this region actually, if we just talk about, in this region, people like both toast and egg. Okay, so we won't be considering this up. We would only be considering this. So that means the answer is 3. Okay. The next one is how many people like toast and eggs both. Okay, so in that case, we'll be taking the common part. Okay, that's lying in between. So these are like 1, 2, 3, 4. So 4 will be our answer. The next one is how many people are in the hotel. So in that case, we need to count down the number of elements in the universal set. And that is how much? 1, 2. So let me just go on with some other color. Okay, so that is 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 is the answer. Okay. And the last question is how many people like neither toast nor eggs? So that means they won't be lying either in E or in T. So we'll be just talking about these 4 elements. 1, 2, not 4, 5 are there actually. 5 elements. So that's the answer. So that's how you just go with the questions. Okay, questions are very easy, but the point is you need to just sit down, you need to relax, okay, and then you need to proceed. And definitely, okay, if you just practice a little bit of the questions, okay, you'll be able to excel it up. Okay, and we'll be practicing a lot of questions, so don't worry about it. It's my responsibility now to just cater you up. So don't worry about it at all. Okay, so let's now proceed with the other topic, okay, which will be much more simpler than this. Okay, but before that, we are having much more questions. Okay, so don't worry about it. So see this question, which says that in the Venn diagram given to you, okay, this E, again this E is coming, so that means the universal set that is actually about the houses in the street. Okay, C means houses with central heating. Okay, the C means houses with central heating. T means houses with a color TV. The color TV is there. And then G is there, houses with a garden. Okay, G is there. And there's a other part which is not included either, is not included in like either of the 3. Okay. Now it is asking you how many houses have gardens. That's the first question. So that means we need to calculate the things of which lies in this set G. Okay, so in that case it will be how much? It will be 40 plus 11 plus 5 plus 3. 40 plus 11 plus 5 plus 3. So that will be how much? It will be 51 plus 5, that 56, 59. So 59 is the answer for the first question. Okay, let's proceed. And it is asking you how many houses have a color TV and a central heating both. So basically, you need to understand one thing, that whenever and is used, so in that case, in your mind should say intersection of sets. And whenever or is coming, your mind should say union of sets. Okay, this is a strategy that we can follow. Okay, so for example, here it is asking you how many houses have a color TV and central heating. So color TV, so that is it will be in set T, and central heating, so C. So we'll be taking out the common elements in this T and C, and that is how much? That is 6 plus 5. Okay, so that means 11. Okay, that's how the thing goes on. Okay, now the next part, how many houses have a color TV and the central heating and a garden? So that means we need to take the intersection of all of them. So now the things becomes very easy for us. So that means we need to take this middle part, and that is how much? That is 5. Simple. Next one is how many houses have a garden but not a TV or central heating. So we need to neglect this thing up. Okay, so how many houses have a garden but not a TV or a central heating? So in that case, we won't be including this intersection part, and we'll be just seeing this thing up and we'll be writing that as the answer. Okay, because this is the only part which does not include either the TV part or the central heating part. Okay, next one is how many houses have a TV and a garden but not central heating? Okay, so that's a question. So if you just see the things up, let me erase it up a little bit so that actually the things are much more clear to us. Yeah. So how many houses have a TV and a garden but not central heating? Okay, now this is also a very easy question to understand. Okay, how? Let's see. So have a TV, so that means it should lie in this, and it should be intersection of this T and G. Okay, for sure, but not central heating, so we won't be taking this part won't be included, so this part only will be the answer. Okay, and that is how much? That is 11. So 11 is the answer. Okay, and then it is asking you how many houses are there in the street, so we'll be just adding the things up. Okay, it's as simple as that. So 35 plus 6 plus 5 plus 11 plus 3 plus 40 plus 20 plus 4, like that, and we'll be summing it up to get the answer. It's as simple as that. Hope you must have got it. Okay, so it's a very easy question. Yes, it can take time, but and I would recommend that you should just do it once more when you just be just looking over this lecture once more. Okay, fine. Now let's talk about these kinds of questions. Again, very easy. So here it is given that a set M is there which are having the elements 1, 2, 3, 4, 5, 6, 7, 8. And set N is there which are having the elements 5, 7, 9, 11, 13. Now the first question is, what is M intercept N? Okay. Okay, I will recommend you to take a 1 minute pause. Okay, 1 or 2 minutes. Okay, just pause the video and try to do it. Okay. Okay, let's start with the solution. So if I talk about M intercept N, so that means I need to take the elements both present in both M and N. So 1 is present, no. 2, no. 3, no. 4, no. 5 is present in both, so we'll be taking that. 6, no. 7 is present in both. 8, no. So yeah, only 2 elements are there, 5 and 7. So that's our answer. Okay. Then it's about M union U. N. So in that case, we need to take all the elements present in both. So that will be how much? That will be 1, 2, 3, 4, 5, 6, 7. We won't be just duplicating the elements as I already told you. Okay, 8, then 9, 11, 13. Okay, so that's how the thing goes on for this. Now the next question is n of n. That means the number of elements in the set n. So you can count it up, 1, 2, 3, 4, 5. So 5 is the answer. And then it is asking you number of elements in set M union N. So we can count this thing up. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 elements plus 2. So 11 elements are there. Be careful while you are just doing this thing up. Okay. And then it is asking you the following. State whether true or false. First question is whether 5 belongs to M. Yes, I think it is belonging to M. So true. Second, 7 belongs to M union N. Yes, it is true. Third question, N is a subset of M. N is a subset of M? No, because there are these elements 9, 11, 13 which don't lie in M. So it's false. Okay. And the next one is 5, 6, 7 is a subset of M. Okay, so yes, because 5, 6, 7 lies inside set M. So this is true. So hope you must have gotten. Okay, so these things are very easy to understand, but yeah, definitely with time you'll be learning more and more. So don't worry about it. Okay, so that's it from my side for right now. We'll be continuing this topic in the next lecture. Okay, thank you so much, dear. Cheers. Take care. Bye bye.